So the next aspect of chemical bonds we are going to treat now is what? Coordinate covalent bond, which is known as what? Dative bond. Coordinate. Which is also known as what? The what? Dative bond. So what is coordinate covalent bond? It's a special case of covalent bond in which the shared electron is donated by one atom only. You know, in covalent bond, the two atoms will donate the shared electron together. But in this case, the only atom will donate the shared electron for the bond. Just like what? Parasitism. You know, in mutualism, the two of them will share. That is covalent. But the coordinate here is a what? We are calling it what? Parasitism kind of what? Of covalent bond. So here the only element, atom that is participate, one atom that participates in the bond will produce the what? The bond electron. So here, this is a what? Is a special types of covalent in which the bond electrons are donated by one atom. Donated by what? By one atom. Let us look at it now. Formation of covalent bonds. Formation of coordinate covalent bond or dative what? Dative bond. Let us look at what? How are they formed? For example, let us look at what? This reaction of between NH3 and hydrogen shell ion to give us what? NH4 plus. This bond that except between hydrogen ion and ammonia air is what? Is dative bond. Yeah, look at the scenario that we have there. NH, NH3. Here we have no what? Lone pair. This one is what? Empty hydrogen. This one has no electron in its body at all. And it's what to what? React. When it react with it like this, the bond electron here, this is lone pair. This lone pair will now share it with what? With hydrogen. So when it tries with what? With hydrogen, you now have what? To now give you this NH, H, H. We have what? H. This bond here. We have H. Then we put what? Ion here. This tells you that what? In this ammonia before, we have how many covalent bond there? 3 covalent bonds. This one with this hydrogen is what? Dative. So we use what? A straight line with arrow to denote what? Dative bond. So in ammonia ion, we have 3 covalent bonds, 1 dative bond. Note. So example 2. Example, this is 1. Then 2. We have in what? Formation of what? Of hydrogen. Formation of hydrozonium what? Ion. So here we have what? Hydrogen, water. We add with what? This. So give us what? H3O plus. So if is that the case, draw the water. We have H, lone pair, plus this empty hydrogen. So what will happen there? This lone pair, it will what? Share it with what? With hydrogen. If you share with hydrogen, we are going to have what? This kind of what? Of structure. This is lone pair electron. This is normal bond. Normal bond. The lone pair one remain one here. This is what? Structure of what? Hydroxyl what? Ion. Here we have how many covalent bonds? We have two covalent bonds, one dative bond. Have you now? So the next one, let us look at what? In the formation of ammonia, boron, trifluoride. So this is what? Here we have what? Ammonia as what? Na3 react with what? BF3. If these react together, we have Na3 ammonia tri what? Boron trifluoride. This is the compound. Let us look at what? The reaction there. We have N what? H3 in this form with lone pair plus BF3. This BF3 is what? Octet incomplete molecule. Supposed to have 8 bond, we have 3. Remain what? 2 to complete. Abi? So you don't want to react with what? With ammonia here. What will now happen here? The ammonia will now donate its lone pair electron to this side. So if it donates its lone pair electron to that side, what are you going to have? You will now have what? Something like this nature. We have what? N what? NH3 bond with BF3 F3. So in this compound now, this bond here is called what? Dative bond. We have 6 covalent bond, one dative what? Dative bond. So another example is formation of ozone. Is what? Formation of what? Ozone. Ozone is what? O3. Let us look at what? Ozone. If you look at what? Ozone, that is ozone react with what? Oxygen molecule react with what? Half of this to give you what? SO3. Let us look at the what? The reaction that happened there. So here, when we have ozone, this is the bond we have here, right? So this is what? 2 lone pair. Now we use the lone pair, 1, 2. For the lone pair, there's yes. It will now react with what? Oxygen. So the pure oxygen here, so oxygen has 6 electrons in atomos what? Atomos share. So it's not stable. We have 1, 2, 3, 4, 5, 6. So it will now donate this lone pair to what? To this man. By share it with him, we are going to have ozone. This is the structure of what? Of ozone. So this is this double bond here. This is structure of what? Of ozone. In ozone molecule, we have what? 2 covalent bond, 1 dative bond. Likewise, formation of SO3. Formation of what? Of SO3. Formation of XO3. SO3 form from SO2 react with what? Oxygen to give you what? SO3 so plus oxygen. So this will now give us what? X double bond with this O and what with this O. That is, here we have what? Lone pair here. It will donate this lone pair to the what? To the oxygen here. Because it has 1, 2, this here. So in SO3, we have one dative bond. And the last one, please be noted, the formation of complex ion. Formation of what? Formation of complex what? Ion. Like, like, yes, like Fe, see this kind of what? Of ion formed by what? They form by dative what? Dative bond. So you have something like this as what? As the structure. We have cyan, 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 cyanide, cyanide, cyanide. And all the cyanide will donate this to what? To the central atom. Compound will be in this form. So any bonds of a ligand with transition element is also what? A dative bond. So that's all about what dative bond. We can see that what dative bond here, the shared electron produced by one atom that is participating what? In bonding. So the last aspect under intermolecular bond is hydrogen, is a metallic bond. Metallic bond. What is a metallic bond? Metallic bond is a bond that exists between metals. It's a bond that exists in a what? In a metals. That's what? Metallic what? Metallic bond. You know, naturally, all metals, they ionize electrons. If they ionize what? Electrons, the metal will become positive charge and the electrons will be moving around the what? Around the metals as in form of what? Of electron C or the localized electron. So the metallic bond is a what? Is a bond that exists in what? In a metal, and it is responsible for properties of what? Of metal, such as what? Boiling point of metal, melting point of metal, malleability, malleability, boiling point, melting point, ductility, and malleability of what? Of metal, and conductivities of what? Of metal. Under what? Conductivities. The metallic bond is a bond that exists within metal. Is an electrostatic force or bond that exists between what? The positive charge of metal and electron C we have in the what? In the metal. So that's the metallic bond, and it's responsible for the what? High boiling point, high melting point, ductility of metal, ability to what? To draw a metal into what? Into wire. Ductility. ability to what? To beat a metal into what? Into different shape, malleability. And the conductivity, metal can conduct what? Electron, can conduct electricity due to the what? The presence of what? Of free mobile what? Electron in what? In them. So, like I said, what? The metallic bond. Let me put it in this way. Let me put it in this way. I said, what metallic bond is a what? Is a bond that exists within what? Within metals. That's metallic bond. Due to the what? The press, due to the what? The electrostatic force attraction between the electron C in the metal and the what? And the charge of what? Of metal. So I said, what? Take for example now. Assume this is a what? An iron sheet. The roofing sheet. And what? It's roofing what? Roofing sheet. So this roofing sheet now, we all know that automatically it will contains what? Iron plus, iron plus, iron plus, iron plus, iron plus, iron plus, we have iron plus, iron plus, iron plus, iron 2 plus, iron 2 plus, iron 2 plus, iron 2 plus. You can see that what? All this iron, this is their what? Their normal formula. But they ionize by releasing what? Electron in their body out. You can see the what? This electron that they what? They lose. You can see that what? In this grooving sheet now, ion, they ionize by release what? The two electron, by release the electron out, they become ion. And this group of electrons that is ionized from the metal, the group of them, they are what? Together, they are called what? Sea of electron. They are called what? Sea of what? Of electron. Or we can also call them what? Delocalized. Lies electron. Delocalized what? Electron. Or electron cloud. So there is a what? Electrostatic force of what? Of attraction, which exists between this sea of electron and what? And metal ion. So that force of attraction is what we call what? Metallic what? Metallic bond. And the force of attraction was explained by electron C theory. The electron what? C theory. Tell at what? The force of electrostatic force of attraction exists between the what? The electron of electron or the localized electron we have here and the what? And the metal ion. And that is what we call what? Metallic what? Metallic bond. And the presence of this what? This C of electron we have, or electron C, is responsible for high melting point, boiling point, ductility, reliability, and the conductivity of the what? Of electron. That is what? The metallic bond. And the metallic bond is a weak bond. Among the all, is the weakest bond among the all the intramolecular bond. The metallic what? Is the weakest what? Weakest bond. So that is all about what? Intermolecular what? Bond. So the last aspect of this case now is what? Is intermolecular what? Molecular bond. Let us look at intermolecular bond within next 10 minutes.